Alright, so the ratio test. We have this infinite series of non-zero terms. Then the series converges if this limit is less than 0. This limit is of the an plus 1 term over the an term. But it diverges if that same limit is greater than 0. And if it's equal to 0, we have this inconclusive. We're not sure. Okay? So this ratio test, or for the series involving expressions that grow very rapidly, such as factorials or exponentials. So that's going to be really important. When you see a problem that involves, especially both of them, if you have factorials and exponentials, the ratio test is probably the way to go. Okay? It'll probably be the easiest way to go. So these problems, once you get them set up, they really aren't too difficult to do. There's a lot of stuff that is going to simplify and give you pretty simple answers. Okay? So let's just go ahead and start off with the first one. So we have this series of 2 to the nth over n factorial. So again, if we're using from up above, it says the an plus 1 term and the an term. How would I actually make the an plus 1 term with this? That's what's going on top, is the an plus 1 term. So what is the an plus 1 term? What's it going to look like? Yeah, everywhere there's an n, you put an n plus 1. And before I forget, we are doing absolute values here, so if you look up at the top, it's absolute values. So if you want to make a note, this also tells for absolute convergence. Because we're taking the absolute value, so this is a test for absolute convergence. It also tells convergence and divergence, so that's also a two-way test if you want to write that down. It's also a two-way test. Alright, so we have the an plus 1 term over top of the an term and the absolute value of it. But if we have a fraction over a fraction, we can actually do what? Yes, so 2n plus 1 over n plus 1 factorial. Then we have the n factorial on top, and we have 2n on the bottom. And don't forget absolute value. So right now, as it stands, does it look like we can simplify anything? Are there any terms that are the same as we're looking at it, though? No, not really. But is there a way we can manipulate it so we can possibly cancel terms? See a couple head shakes. Eric, what do you see?
You have the factorials, and so since your factorials and minus everything below, you can take the bottom or multiply by all numbers below. You can take the bottom and you just do n plus 1. The next term is going to be multiplied by n factorial.
Yes. Okay. So we can do that on the bottom. The n plus 1 factorial. When you do a factorial, like 5 factorials, 5 times 4 times 3 times 2 times 1. Well, if you subtract 1 from this term to get the next term, well, what's n plus 1 minus 1? You just get n. So n plus 1 times n factorial. Okay, so we kind of split that up. Is there anything we can do on the top now to maybe simplify a little bit? N factorial doesn't really simplify. What about 2n plus 1?
Separate into 2n times 2.
2n times 2 to the first, or just 2. Exactly. Because if you have like bases, 2 times 2, What do you do with the exponents when you multiply? Add them. So 2n times 2 to the first should be 2n plus 1. So that's how that can be broken up. Very good. Now, what all cancels? Well, we have a 2 to the n and 2 to the n that cancel. We have an n factorial and an n factorial that cancel. That's pretty nice. So it leaves us with 2 on top and n plus 1 on the bottom. Remember, we're in absolute values. So now the limit of the absolute value of the ratio here, of the an plus 1 over the an term, we've simplified this ratio. Is it the limit less than 1, greater than 1, or equal to 1 as you go to infinity? Do we know what the limit actually is? 0, less than 1. So this test tells us what? Converges by ratio test. So as long as you can figure out what needs simplified and canceled out, this test really isn't too bad. Are we okay to try the next one? All right. So we are given the series of n squared times 3 to the n plus 1 over 2n. So we're going to take the limit as n approaches infinity. We have these absolute values. We need the n plus 1 term, so what's that going to look like?
N plus 1 squared times 3n plus 2 over 2n plus 1.
N plus 1 squared, 3 to the what power?
N plus 2.
Yep. Okay, over 2n plus 1. Now, I'm going to skip a step here. We said that when we divide by the fraction, it's multiplying by the reciprocal. So let's just go ahead and do that all at once so it's done. So that brings 2n, 2 to the n to the top, and n squared times 3 to the n plus 1 to the bottom. So we're now at the point where we need to try to break up anything in the top and the bottom to see if we can cancel anything and reduce a little bit. So, is there anything on the top that we could change? Anything on the top?
Yes.
Okay, what would it be, Eric?
You can take, like, given the last problem, you can separate the exponents.
Okay, so I get 3,
Squared times 3.
yeah, 3 to the n times 3 squared, very good, and 2 to the n. So that's all that can really be done on the top. On the bottom, splitting it up just like Eric said again, 2 to the n times 2 to the first, or just times 2. N squared stays the same. But then we can also break up this 3 to the n plus 1. So 3 to the n and 3 to the first. And absolute values. Now I have a 2 to the n and a 2 to the n. I have a 3 to the n and a 3 to the n. What about 3 squared and 3 to the first? Yeah, it's going to cancel on the bottom and it'll leave me with 1 3 on the top. So I get 3 n plus 1 squared. On the bottom I'm left with 2n squared. Is there anything left to cancel, or did we cancel everything? Any other exponents to break apart, or do we think we're okay here? Can we take the limit here? Alright, so the limit, as you approach infinity, of this, the absolute value of this, the limit would be what? Pay attention to your powers. 3 halves, the ratio. That is greater than 1, so what does this test tell us? Diverges by ratio test. Diverges by ratio test. Alright, not too bad. So for the last one, what I want you to do, since we have some time, start this one on your own and then we'll go over it. So follow the steps, the an plus 1 term over an, and take the limit. Anybody completely stuck or at least able to get help from a partner? Give me a thumbs up when you and your partner are both done. Caitlin, are you both done? At least have an answer?
Yeah, I have.
Okay.
Yeah.
Okay. You guys have an answer?
I think
Okay.
probably wrong.
Alright, we're going to check the answer. We'll see who's right, who's wrong, where the confusions are. Alright. So the first step, did everybody at least get this correct? Where you have your an plus 1 term and you multiply by the reciprocal? We're okay with that. Alright, so what is the next term? Can somebody start listing out what the top would be when you're trying to expand it so you can cancel terms?
Upper would be n plus 1 factorial.
N plus what, sorry?
N plus 1 factorial.
Okay.
N plus 1. Oh.
Is there something missing there? Should be something before that.
No, because it's, oh, because I did the original divided by the
Okay. Yeah, you have to do the an plus 1 term divided by the original.
This is what I got. I don't know. I don't really understand how you can. Like for the one over here, we got n plus 1 to, and then we back n plus 1 to the factorial, and then we simplified that to n plus 1 times n to the factorial, right?
Yes.
Like how can we do that and not?
Okay, so if you have 5 factorial, what is 5 factorial?
Just like 5 times 4 times.
Okay? We're okay with 5 factorial. If I change this, I can reduce this to 5 times 4 factorial. So before I write out what that is, what is 4 factorial? 4 times 3 times 2 times 1. But what if I do 5 times 4 factorial? Well, I would have 5 times 4 times 3 times 2 times 1. So these are the same. This is like saying this is, in terms of that one problem, n plus 1 factorial, and this would be your n plus 1 to the n factorial.
Okay, so from this one I got n plus 2 times n to the factorial.
N plus 2, and then you had what?
Times n to the factorial.
N plus 1. One term less. If you have n plus 2, subtract 1 away. The next term would be your n plus 1 term. See over here, all we did from n plus 1 to get to n, we subtracted 1. So if we did the next term, we could do this again over here. If you're referring back to this example I have n plus 1 times n factorial. If I reduce this further, I could have n plus 1 times n minus 1 factorial. I could keep reducing that. The next term is always just going to be 1 less and 1 less and 1 less. Because as you move on the factorial, look, 1 term less, 1 term less. So this is your original. What's 1 term less? Well, n plus 1 factorial. The 3 to the n, does that simplify it all? No, I just write 3 to the n. So are we okay with the top right now? Caitlin, we're okay with that?
Yeah.
Autumn, okay with that? All right. So now we're going to the bottom. 3 to the n plus 1. Can that be broken up at all? Yeah, we can get 3 to the n and 3 to the first, or just times 3. And do we need to break up the n plus 1 factorial at all? We could, but do we need to? No. Okay. Are we all okay up to this point now? Now I can cancel anything I have in common. So the n plus 1 factorials, and I have a 3 to the n and a 3 to the n. That leaves me with n plus 2 over, don't forget your absolute values, over 3. So now, if I take the limit of this as n goes to infinity, I get what? I get infinity, and that is greater than 1, so what does that tell me? Diverges by ratio test.
Why can't you use the nth term for this term?
You could. You most certainly could. If you see this and you recognize you could use the nth term, because we always say try it first, so you could and it would work. But if you didn't do that, or you forgot and you just see y factorials and exponentials, I know that deals with the ratio test, you can use it too. So there's going to be problems where you can use 2, 3, maybe 4 different tests. But this is just one possibility. When you see those factorials and exponentials, that might get your brain thinking, okay, I got to try ratio test. Okay. So if you forget to do an nth term test, it doesn't mean it's not going to work with anything else. Okay. There are multiple possibilities. That's why we say with some of them, if it's inconclusive, try another test, because you can use multiple tests throughout. Okay? Now, what we're trying to teach as we go through this, though, is some of them, they fit a pattern. If you see one like this, you're thinking, okay, that's like the ratio test. If I see this ratio to a power, I'm thinking, oh, that's a what? If it's a ratio to a power? geometric series test. So there's patterns that follow specific tests, but that doesn't mean it won't work in another test. Okay? The other test may be a little more difficult, but it still may work in another test. Any questions about the ratio test? All right, so tomorrow we will go on and do the root test. This is our last test. We'll do the root test tomorrow. Then we have a big paper of review problems we'll go through, and it's going to be a variety of all the tests. So we'll start that tomorrow and Wednesday. But the rest of class today, I have the note cards up front. If you didn't already, if you want to take that, make your ratio test note card, and then use the rest of class to either work on homework or study the test. Okay.